Alright guys, we're doing Module 2 test review for geometry. All of this was based on angle relationships and whatnot. So let's start with this first page here. You can see we have a transversal right here. And although these lines aren't said to be parallel, this is still a transversal line cutting between two lines, and there still are angle relationships that we're used to having, such as the alternate interior, exterior, consecutive, corresponding, and vertical that we have listed below. So let's start with interior. So interior is going to be that 3 and 6. So I'm writing angle 3 and angle 6. It's going to be 4 and 5. And notice that, or just remember that, alternate interior angles are congruent angles. Looking at exterior, we've got 1 and 8, angle 1 and angle 8. We've also got 7 and 2. So that's angle 7 and angle 2. And again, these are congruent angles. Now let's look at the relationship of consecutive angles. So remember, consecutive angles are on the same side of the transversal, such as 3 and 5, and they're on the insides of the lines that the transversal is cutting through. So angle 3 and angle 5 are a pair of consecutive angles, and so are 4 and 6. But these ones are not congruent like the interior and exterior were. These ones add to 180. Corresponding angles, those are going to be ones that are in the same spot. So those are going to be angles like 1 and 5. So out of these 4 angles and out of these 4 angles, 1 and 5 are in that same spot. So those are corresponding angles. So angle 1 and angle 5. Then we've got 3 and the same spot as 7. So angle 3 and angle 7. 2 and 6. So angle 2 and angle 6. And 4 and 8. These angles, just like the first two, are also considered to be congruent when the lines are parallel. Vertical angles, no matter what, are going to be congruent, and they are also across those lines that cross. So let me show you that. That is going to be like 7 and 6. There's an X here, and 7 and 6 are on the opposite sides of the X. So angles 7 and angle 6 are vertical angles. We also have 5 and 8. We have 3 and 2. And we have 4 and 1. And just like I said before, they are all congruent, same measure. All right, let's move on to the next page here. We have, if line A is parallel to line B, parallel being a keyword too, find the value of the variable. So we're trying to find x, it looks like, in the following figures. So I want to represent that those lines are parallel in a better way than that. So I'm going to try to draw those parallel triangles. I'm going to try. I didn't say I was good at it. So I'm going to draw those parallel triangles. Alright, those are parallel lines. So that means that makes this angle and this angle alternate exterior angles. So I'm just going to write that so I remember. These are alternate exterior angles. And based off of the page we just went over, alternate exterior angles are congruent. So that means we are going to take that 3x plus 1 over here. We're going to set it equal to the 2x plus 41 because they're equal, they're the same, because there are parallel lines involved. And now that I have my equation set up, all I've got to do is solve. So I'm going to combine this as a like term with this. And since there is an equal sign involved, I have to kind of draw my fence, and I have to subtract it from one side in order to bring it to the other side, and subtract it from the other side. I get 1x, or I can just write x because x is also 1x, doesn't matter. I'm going to bring everything else down, keep my equal sign on the fence there. Then all I've got to do is subtract this 1 because it is a like term with 41 because they don't have an x attached. So that cancels. Subtract 1 from 41, so that means x is 40. And remember, we're just solving for the variable, so we don't need to solve for the angle measurement. But make sure on your test you're paying attention to that because it might ask for the angle measurement. And if you just solve for x, you'll notice that's not the angle measurement. If I plugged it back into this 2x plus 41, 40 times 2 is 80, and 80 plus 41 is 121. So that actually doesn't look like an 121-degree angle, but regardless, that's what it would be. I wonder what this one would be. So this would, yep, 121 as well. Yeah, these are acute angles. You blame Mr. Carpenter for that. He wasn't paying attention. He should have put them here. These are more of the obtuse angle, eh? Anywho, moving forward. So same thing with this next problem, number 7. So we are representing line A and B as parallel lines. So if these are parallel, that would mean, even though this is not a transversal we're used to looking at, that still means that this angle plus this angle, these are consecutive angles because they're on the same side of the transversal, on the inside of the parallel lines. These are consecutive angles. And we're not going to pay attention to this one yet because I can tell that this and this angle measurement have x's in them, but this one has a y in it. So there's really nothing I can do with that yet. So let me just kind of ignore everything I've written here for a second. I'm going to focus on these two. So remember, on the first page, we said consecutive angles equal 180. So I'm going to write that they're consecutive angles first. And I'm going to write 3x plus 5 plus 2x plus 25, because I know if I add these two angle measurements together, I get 180 degrees. So again, combining like terms, but these are not on different sides of the equal sign, so that means I can actually just combine them the way they're written. 3x plus 2x equals 5x. And this 5 and 25 are also like terms on the same side of the equal sign, so I'm just going to add them together because it's a plus 5 and a plus 25, and that makes a plus 30. Bring my equal sign down on the fence. Bring my 180 down. You guys are used to these. Subtract 30 on each side. You get 150 equals 5x. Divide out the 5. You should get x equals 30. Now, how am I going to solve for y? Because honestly, the only angle relationship I see is that this angle and this angle are vertical angles. So I know that vertical angles are congruent, but at the same time, I still don't know this angle measurement. So I'm going to have to take that 30 and plug it in for x. So that becomes 3 times 30 plus 5, and I should get 90 plus 5, which is 95. So now I know that this angle measurement right here is 95. So that means if that's 95, this angle measurement is going to be 95 as well. So now I'm just going to say 3y minus 2 equals 95, and I'm going to solve for y now. Add 2, I get 97 equals 3y. And let me move my paper down a smidge. Divide out the 3. Y, unfortunately, equals an ugly 32.3 repeated. But that's y. All right, let's move. All right, on this next page, I am finding the measure of an angle indicated, and if it's not possible to find its measure, say so, and if you can find it, circle the reason that's true. So if I'm looking at that first one, I can find that. Let me actually zoom in here. I definitely can find that question mark, right? And the reason why is because of consecutive angles. So the question mark equals 80 in this scenario because I know consecutive angles add to 180, and I should subtract the 100 from the one side, and I'll get 80. So this is my answer. Looking at the next one, I can find this question mark, and I think it's 113. Oops, I should be writing my degrees. How dare I? All right. And the reason I can find that is because this is alternate interior angles. These are both on the same or opposite sides of the transversal and inside of the parallel lines. These are interior, alternate interior. Next one. So I've got 53 and question mark. I can find question mark. It's also 53, and the reason why is because I've got parallel lines, and these are corresponding angles. They are in the same location out of these 4 angles and these 4 angles. They are in the same spot. Because the lines are parallel, I can say this is 53 degrees. Okay. Let's look at number 11. Ew, slope. You guys know slope, don't you? All right, slope. So you are remembering, so when you're given 2 points, like 4, 5, and 8, -2, you're using the formula m equals y2 minus y1 over x2 minus x1. Oops. So I'm going to label those points really quick. This is x1, y1. This is x2, y2. So if I plug that in, I would get m equals, well, y2 is -2 over there. Oops, I'm not putting commas. I'm subtracting. And then x2 is that 8 minus x1, which is that 4. And I end up getting a slope of -7 over 4. So that means, remember with slope, you rise and you run. So I rise down 7, run 4. Rise down 7, run 4. Rise down 7. So you'll notice that the line begins to slope. This has a negative slope. It's going down. And that makes sense because it is a negative number, or a negative fraction anyway. All right, what is the slope of a vertical line? Well, it is undefined. The reason for that being, when you get 2 points of a vertical line, so like we got 2 points last problem, your 2 points, when you plug them into the formula, you might get something at the end like 2 divided by 0. And the thing is, you can't divide a number by 0. That is why you get undefined. If you plug 2 divided by 0 in your calculator is going to go crazy. You cannot divide a number by nothing to try to get an answer. You can divide 0 by a number, and you will get 0. And this type of slope is what we call zero slope. And that looks like a horizontal line when you put it on a coordinate plane. So a vertical line, remember, that's going up and down, is undefined. But a horizontal line over here is zero slope. Really important things to remember. All right, last problem on this page. What is the slope of the line in the graph? Well, let's figure out the points. We've got 3, 3, and we've got 6, 4. So we've got 3, 3, and we've got 6, 4. So if we plug that into that formula we had up here, might be helpful to label our points, x1, y1, x2, y2. So m equals, well, y2 is 4 minus y1, which is 3, over x2, which is 6, and x1, which is 3. So when we do 4 minus 3, we get 1. When we do 6 minus 3, we get 3. So our slope is 1 over 3. And you'll notice that if you go to this point on the line, you would rise 1, run 3, and you'll land on that next point. And if you actually rise down 1 and run backwards 3, you will also still land on the line. So the line follows the slope. All right, so on this last page of our review, we are trying to look at this next problem that has an equation in it. And we want to put that problem in slope-intercept form. And remember, slope-intercept form is y equals mx plus b, b meaning the y-intercept, which is the point on a coordinate plane where a line passes through the y. And then m being our slope. So, and of course x and y being our coordinates that would be coordinates that would fall on this line on the coordinate plane. So if I have 4x plus 5y equals 10, what I'm going to need to do is I'm going to need to get y alone. So first I'm going to subtract 4x from each side. That cancels. Now I have 5y equals 10 minus 4x. Then I still need to get y by itself, so I need to divide out the 5. But whenever I divide out by a 5 and I have 2 things on the other side, I need to divide the whole thing by 5. So that means y, actually I'm going to write it up here, y equals, well, 10 divided by 5 is 2, and a negative 4x divided by 5 is a negative 4x divided by 5. Or we might even write it like this. And if I really want to get technical and I want to put this in the same location as it is in slope-intercept form, I just need to scoot these things around. Remember, this is a positive 2, so if I rewrote it, I would write y equals a negative 4 over 5x plus 2. Now it's in slope-intercept form. So what is the slope of the line given by the equation? Well, look, we have already got it. It's right there. That's the slope. So that would mean we rise down 4, run 5. Rise down 4, run 5. All right, is the line in problem 14 parallel, perpendicular, or neither with this line? All right, so notice the slopes. So if the slope in the line they just gave us is 5 over 4, and the slope in problem 14 is a negative 4 over 5, notice you're going to be rising down 4 over 5, down 4 over 5. And on this line, you're going to be rising up 5 over 4, up 5 over 4. So they're going to be like perfectly crossing each other. they're going to, I know it doesn't look like it, but they are making 90-degree angles. They're perfectly crossing each other. Those should be 90-degree angles. So these are perpendicular lines. You'll notice that if this was our given slope, the perpendicular slope would be the reciprocal fraction, which is flipping the numbers from the bottom to the top and the top to the bottom and then making it negative. Those make perpendicular lines. To make parallel lines, I think that's in the next question. Nope, it's not. Just so you know, to make parallel lines, you're going to have the same slope. So that would mean if I had a slope of 2 over 1, to have a parallel line, I'm going to have also a 2 over 1 slope, but different y-intercepts. That is important. So parallel, same slope, but different y-intercept. Perpendicular again, if you want to write this down to remind yourself. The slopes are reciprocal fractions, reciprocal, and one is positive and one is negative. Those make perpendicular lines. Other than that, we know all kinds of different kinds of slope now. Parallel, perpendicular lines, we know zero slope, we know undefined slope, and we know just normal regular slope as well. Get out of here, arrow. All right. Are the following lines parallel? If so, what theorem tells us so? So, these lines can be parallel if the question mark is equal to 50 degrees. Then I can call these lines parallel. And this is because these two angles would have a relationship of the consecutive angles postulate. That means they add to 180, and they're on the same side of the transversal and on the inside of the parallel lines. That's what consecutive lines are, or that's what consecutive angles are, and so that's the consecutive angles postulate that we learned. Okay, these lines could be parallel if the question mark equaled 81 degrees. And that postulate, or I'm sorry, that theorem is the corresponding angles theorem. So these two are on the same location of these intersections of the parallel lines to the transversal. They are both on that bottom right corner. And so if these lines were parallel, then that would mean the question mark would have to be 81 degrees, being corresponding angles. All right, our last problem is a proof, and we are given that angle 1 is equal to angle 7. So I'm just going to write that. Angle 1 is equal to angle 7. So we know that because it's given, but since we know that, we can assume that these are parallel lines because those are alternate exterior angles. So if they are congruent or equal to each other, then that means they're alternate exterior, which means they're parallel lines with a transversal. But right now, since we're given that, we just write given. Then it says if angle 1 is congruent to angle 7, well, I guess I said that. That's alternate exterior angles. And we can assume that A is parallel to B because of the alternate exterior angles theorem. So the last one, angle 3, is congruent to angle 5 because of the alternate interior angles theorem. Oh, that's terribly written. Theorem. All right. This has been your Geo Module 2 test review. Good luck on the test.